Hello everyone, and welcome to part 1 of the Trig Mastery Check Solutions video. We're going to get started here. Determine the quadrant in which the determinal side of an angle of 215 degrees lies. Well, you may be able to do that in your head, but I'm going to do a quick sketch of 215 degrees. That is down here. The terminal side, meaning where it ends, is down here in quadrant 3. All right, given an angle of 340 degrees. Its reference angle is, well, let's draw 340 degrees, just shy of 360. That reference angle right there is going to be 20 degrees. It's going to be 360 degrees minus whatever I have been given. So that is a 20-degree reference angle. Now we're going to transition into thinking graphically and talking about something we haven't talked about specifically in a while, and that's domain and range. Let's talk about the range of the cosine function. The cosine function, generally speaking, looks like this. There's the parent function from 0 to 2 pi. Here's pi. What I'd like you to think about in this question is the range. So that means all of the possible y values for the cosine curve. Well, the high point of cosine is 1, the low point is -1. It's continuous all the way along that curve, and so the range is all y values from -1 to 1. You could write that like this, or you could write it in interval notation. All right, now we think about the domain, which is all the x values of the sine function. Quick sketch of our sine function looks like this from 0 to 2 pi. There's no domain restriction here when I ask you this, so what I'm asking you to think about is y equals sine x. If it just keeps continuing, here's what it looks like, right? The domain of y equals sine x is all real numbers. And you could write that in a number of ways, negative infinity to positive infinity with parentheses. All right, so now in 5, determine the exact value of the cosine at 5 pi over 3. All right, I am in the unit circle here, and so you can use your pi plate, or your unit circle, excuse me, or you could say, okay, that's 5 times pi over 3 is 60, so that's 300 degrees, okay? And the cosine at 300, it's helpful for me, because I'm so visual, to draw this. So 300 degrees would be down here, with a reference angle of 60 degrees. And down here, the coordinate there is 1/2 comma negative square root of 3 over 2. Since I'm asked about the cosine, that's the x value, or the side adjacent, and that is 1/2. Now I'm thinking here back still in the unit circle for number 6, to find an angle coterminal. Well, terminal means end, and co means together or shared. So I'm looking for an angle, okay, that's coterminal or ends in the same place as -7 pi over 12. Well, if I decided to take this unit circle and make it over pi, make the units pi over 12. Usually we do pi over 4, or pi over 3, or pi over 6. But now if I'm going to do pi over 12, does it make sense that there would be 24 sections in this unit circle? And if I make a rotation of -7 pi over 12, well, let's see, there would be 6 pi over 12, -7 pi over 12. Oops. What I'm looking for here is, because if I'm dividing pi over 12 into 12 sections, then the whole thing would be 24. So I'm going -7 rotations. That's right about here. And what I'm thinking about is -7 pi over 12. Well, how would I get the rest of the way here? That would be going 24 minus 7. Does that make sense? The whole minus the rotation that I've done would be 17. So I'm looking at a rotation, or a radian length of 17 pi over 24. Because this one is 2, oopsies, I think I've messed this one up. Let me think about this. Pi over 12, so I've got to stay in pi over 12. forgive me. I'll give an explanation for this one that is correct in the next video.